All right, so we're on to part two, and we're going to get a little bit more into the lab now, which is about estimating home ranges. But first I want to talk about what a home range is. And if I can get it to forward here. Home ranges are basically the area that an animal uses to meet their daily needs. Home ranges can overlap with the home ranges of neighboring animals, both of the same species or different species, and it's estimated by the presence of an individual animal at a location at various times. It's a dynamic process. The size of the home range is an important thing to study because it can be an indicator of habitat quality or the distribution of resources. Animal behavior and territories. But I want you to keep in mind that the reality of these point locations is suspect. We're recording locations at snapshot points in time, and we don't know why the animal is in a certain place. We just have a radio collar blip that puts the animal at point XY, at a certain point in time, but it may not actually be the home range. It's possible that the animal was being chased by some kids and, ended up across, the city from where it's supposed to be. Who knows? So we do have to be suspicious of the data in general and apply, some precision limitations there, I think. And just, keep thinking about uncertainty that way. And also, just like I said before in part one, just keep in mind that this can apply to all, many other creatures, fish, birds, turtles, humans. It's not limited to coyotes, of course, by any means. The data for this lab was collected by new Dr. Brian Kluver and Dr. Eric Gazy, who also gave us kind permission to use the data. Brian just successfully completed his PhD at Utah State, and Dr. Gazy is a behavioral ecologist at Utah State University, working with coyotes, wolves, and foxes. It's a very cool data set, and we'll talk a little bit more about the data set in general. But there are two basic methods for collecting animal location data. One is to use radio collars. And this basically entails putting on a transmitter on an animal, like this. Look at how happy they are. Oblivious turtle. And then basically working to pick up the signal with the receiver. And so sometimes you'll see people like this wandering around. The other way is to use a GPS collar. The GPS collar also must be put on an animal. They usually aren't quite so fabulous looking as this, but one can hope. The collar captures and stores the GPS location of the collar, which is presumably still attached to the animal. And this one's for an elephant. And the user can define the periods of time in which it's collected. This cat really loves wearing his GPS collar. This is so demeaning. But look at it, it's that really fancy one. Of course, you deserve it. And now the secret's out. Who is the master now, my little friend? We know where you go all day. I happen to be living right now in a neighborhood in Ireland that has a feral cat problem, and this brings me a little bit of joy. Okay, and I know where they go, by the way. They come into our house if we leave the door open a crack. They're very, very naughty. Anyway, okay, so there are important differences to note about VHF radio collars and GPS collars. The accuracy of the radio collars can be between 100 up to 500 meters, while the accuracy of GPS collars is much better, usually under 10 meters or less, which means that for detailed habitat use or for smaller animals that may have a smaller home range, the GPS collar is probably required. The advantage of VHF radio collars is that they can last 5 to 10 years, while GPS collars typically only last 1 to 2 years. And so you have to keep that in mind, when you're dealing with mortality studies or something like that with very long-lived animals. You might be better off with a radio collar, especially if it's, an animal that has a larger home range. You're golden. You'll often hear the word telemetry associated with radio collar use. Telemetry basically refers to the remote transmission of data to a receiver, and it requires a transmitter on the animal and a receiver, usually a human standing there with an antenna. The human with the antenna usually has to go to 2 to 3 different locations to pinpoint the location of the transmitter or animal, and that's what's called triangulation. With GPS data acquisition, the user pre-programs how and when the data is collected. The collars can communicate via satellite, or just using an internet connection. And the data can be downloaded hourly, daily, whatever, depending on the quantity or quality of the data that you're collecting, or the collar can even store the data. And so, how do we use this collar data? Well, the locations are taken at regular intervals, and the locations are recorded as coordinates. So first, you're going to plot them up. And then we can relate these locations to the landscape. We can calculate movement, we can calculate spatial trends, seasonal trends, activity patterns, home ranges, and resource use and habitat selection. And there is a lot of information that can be extracted, combining the locations and information about the animals. Think about knowing the age of the animals or the sex of the animals, or just different characteristics of the animals, and combining that with the landscape, we can really start to understand these critters quite a bit more. So that's it for the end of part 2. I'll pick it up with part 3.